switch channels. Switch channel. Is this working? How do I expand this? Beautiful. The heck? Oh, I should probably log in. Hello, welcome to the live. I'm just setting things up. Thank you for watching. I do appreciate it. Alright. Storms. Very stormy. Should probably turn this on. Alright. Ooh, yeah, that's not looking good for Central Texas there. Basically what this parameter does is it tells you what the probability of the conditions for severe weather lining up are. As you can see here, 42%. That's pretty high. Basically what this parameter does is it tells you what the probability of the conditions for severe weather lining up are. Alright. Let's look at these. Just disconnect. Hang on. Let's go to the tools. Seems to be working now. I don't know. It's being goofy. Alright. Let's take a look at these. The good old H triple R. As you can see here, we got these storms actually have a pretty decent inflow of moisture and instability right here. 2,849 joules per kilogram. That's pretty good. All right, I'm gonna turn this. All right. Well, that's still streaming. I'm gonna go live on my TikTok. So, just wait a second. Hello? I'm now live on my TikTok. It's the first time I've been live on YouTube and on TikTok. It's great. I will put you right here. So, this is just a pre-stream. The real stream is going to start at 8:45 p.m. on the dot. I'm just getting things set up for now. Alright. Okay. Can you all see this correctly? I think so. Well, I mean, I know you guys can't, because you can't see it. But, jeez. The thing about this is you don't really want to trust the H triple R more than like 20 hours out, because it gets pretty inaccurate. Right. Yeah, looking at this, it's pretty decent moisture quality and pretty robust cape profile. Let's just go back here and let's get a box sounding of this. Look at this cape profile. That's kind of wild. It's 2,212. That's definitely enough to yeah, that's definitely enough to spark some severe weather. Let's check the ensembles again. Not the EPS. I'm gonna check the GEFS. What I'm looking for is I'm looking for some similarities in the two model outputs. That's how I know that there's enough consistency to post an update. Sorry if my computer's screaming like a banshee right now. The fan has something wrong with it. Oh my gosh. Buy it. Just go back a little bit. By the way, this is my first time doing this, so don't give me any whip about it. I'm just kidding. Almost time to start streaming. It's currently 8:30 p.m. Alright, people. And just to give you guys a glimpse at what I'm looking at, that's what I'm looking at right there. Alright. I'm sorry that you guys can't see it. Everybody on my TikTok, sorry that you guys can't see it, but hopefully I will get that fixed soon. I know you guys on YouTube can see it, but I'm gonna actually end it on live. And for now, I got a whopping 3 viewers. That's crazy. Thanks for the like. Alright. Sorry if things are kind of slow right now. Alright. Almost time. And let's be completely honest. I know nobody's gonna watch this. But I can repurpose some clips for my content, so you guys aren't winning. I'm winning. Alright. I'm so sick right now. How are we all doing tonight? My level just jumps from 42 to 65%. That's funny. Alright. I think I have everything set up now. Oh, this is so stupid. I really wish I could. So stupid. Alright, I'm gonna. Oh, accidentally liked my own live. That's always great. But, nobody's gonna watch it anyway, so. Woohoo! The struggle with being a small creator. Or I actually think I can do it like this, so. Ugh, that's kind of painful. So I think I will do it like that actually. As you can see, what I've done is like flipped it around. I'm a super mega genius when it comes to technology. I cannot figure out how to connect this darn thing to TikTok if my life depended on it. So I sincerely apologize for any inconveniences that people might have. 5 minutes until I go live. I'm just gonna post on my Instagram that I'm live right now. Oh, so stupid. My nose is so stupid. I wish it would actually work properly. Here. You want something entertaining? Watch my cursor go back and forth. I'm almost done posting it. So check out TikTok at Ben Haley underscore WX. Alright. Hopefully I don't look super unprofessional right now. Please pray for me. I think that should work. Alright, starting my live on TikTok in 3, 2, 1. We're now live on TikTok. I have to do it this way, unfortunately, because my stupid OBS thing will not work. So that's how it's gonna be for now. But you can see the model, you can see my cursor, so everything should be fine, and I'm assuming you can hear my voice as well. Alrighty, so let's start. So my concern for severe weather is going to be starting on Thursday of next week. Let's just go to that and see. Right here, we have a big region of gray, and that equates to roughly about 1 to 5% chance that the conditions will line up for severe weather. What the heck? Oh, sorry. I need to turn on Do Not Disturb. Great. I'm sorry if this is shaky, but that's just gonna be how it's gonna be. So, this is for the GFS. Let's go to the EPS. This is another prominent ensemble. Hang on, let me invite all of my viewers to go as live. Can I invite all my viewers? What the heck? Oops. Okay. So, here's what I'm laying down. Alright. So got this severe weather possibly setting up over the southern plains. We don't care about the southern plains because we don't live in the southern plains. But this could actually start to affect us going into number one this weekend. That's our first period where we could start to see some issues. And number two, we could possibly start to see some issues next week. But next week is going to be from a different system, and we will get into that in a couple of minutes. So, starting this week, the issues really start on Saturday. As you can see, there's a very wide area of this gray. And what this gray is indicating is not good stuff. This is the chances that the ingredients will come together for severe weather. That's what that's really indicating. All right. And as you can see, let's go to the ML Cape. So obviously we have a big patch of Cape right there. But as time goes on, that's going to start to float over, and by the weekend, this area of instability will be over parts of Georgia and South Carolina. And this is where our issues start. Unfortunately, I'm going to have to end the live on my phone because it's quite literally driving my percentage down like 20% per second, which is gay. Whatever. I had a total of 1 viewer on that stream. That's great. It means I can focus all of my attention to YouTube. So we got this layer of Cape right here. It's like 100. I'm sorry, brain fart. But yeah, as we go into the weekend, we can start to see a lot more Cape setting up over parts of southwest Georgia into South Carolina, maybe into North Carolina as well. However, South Carolina and North Carolina aren't exactly very certain right now. It's still like almost 48 hours out. So let's look at the one of the smaller convection allowing models. And I need to go to a previous run because it is in fact not working. Okay, good. So I can hear this here. What the heck? So we can see the surface-based Cape, right? Now what surface-based Cape is quite literally just Cape from the surface. And what Cape is, in case any of you guys don't know, it's just the amount of energy that an air parcel has, which an air parcel is just a packet of air, if I'm being completely honest. Surface-based Cape is just the amount of energy that any blob of air that you pick from the atmosphere has as it's rising. Sometimes the Cape is super high, and sometimes it's low and norms. Alright. So, as we go forward in time, we can kind of see this big blue blob of Cape. Now, this is high Cape. We're talking like almost 3,000 joules per kilogram in parts of Louisiana. There's some parts in Oklahoma, Texas, Nebraska, you name it. But what's going to happen is nearly all systems in the U.S., all weather systems, tend to go east. Now, what our main concern here is whether the cold front is going to run out in front of this moisture before the moisture can flow farther east. And that's what we will see now. As you can see here, it's really pushing up against moisture is really pushing up against that cold front in parts of Texas, Louisiana, Arkansas, all the way up through the Ohio Valley into Pennsylvania, maybe parts of New York. However, we don't really need to worry about this top one. It may create a small little isolated threat here and there, but this bottom section has a lot of energy to it, and I can actually pull up a sounding. As you can see here, marginal tornado. Don't worry about that right now. That's never accurate, but as you can see here, this photograph is pretty messy, which may put a hamper on severe weather for a little bit. But take a look at this 0 to 1 kilometer shear relative velocity. That's 95 meters squared per second squared. Now what this means, that might sound like a whole bunch of yada yada nonsense to you guys, but what it is actually telling is how much energy is available to rotating updrafts in the atmosphere. In other words, how much energy is available for tornadic supercells. That is a very important number. Now, typically, we want this number to be above 200 to 300 meters squared per second squared. Right now, it's just 95. So, might not get a whole lot of rotational action from this system. As always, we'll have to just wait and see what happens. But as of right now, it doesn't exactly look like a super tornado leaning event. I just ripped a wind sheet. A wind sheet? What the heck? I'm sorry, I'm tripping right now. I just ripped a dryer sheet. This is not a wind sheet. I don't even know what that is. Anyways, so looking at the low relative humidity for this sounding. This value is important because it tells you, well, how humid the air is at the lower levels. If you think about it, the air is rising from the lower levels to the mid-levels, and when the air gets to the mid-level, it falls as rain. So the more humidity you have at the lower levels, the more efficient rain is. And as you can see, it's pushing 96%. So what happens when rain evaporates in a downdraft? Well, I'll tell you. When rain evaporates in a downdraft, it tends to accelerate the air down towards the surface. Because evaporation takes energy, and it takes more energy to evaporate something than it would to cool it down a degree. So what it actually does is it sucks the temperature out of the air. The temperature, that's so amateur. It sucks the thermal energy out of the air, and it out of the air inside of that parcel and puts it in the air around it. Well, what do you have now? You have warm air on the sides and a cold air parcel, so that's going to sink to the surface. And this is actually parameterized. I don't know what the word is. I'm not smart enough. In something called the D-CAPE right here. This stands for downdraft CAPE, and it's the exact opposite of the CAPE. To remember, CAPE is convective available potential energy. It's the energy available to rising air. This is the energy available to sinking air. And typically we look for D-CAPEs of over 500. Look at this value. That's almost 623. Not almost 623. What am I talking about? This is 623 joules per kilogram. And per kilogram, if you know anything about air, 1 kilogram of air is pretty big. Typically measured in liters, but can't really do that in the air because it's more complicated than that. So anyways, 623. So we could actually see a pretty decent wind threat with the storms, and we'll actually look at the reflectivity, the parameterized reflectivity. And as we go forward and see big storms over here, that's expected. There's a pretty volatile setup in Oklahoma, Texas, all those places. But as we go forward in time, that system's going to get yeeted off to the north because nobody loves it. And then there's going to be some more systems. And look at this. Look at this little band of storms. Now that's going to move forward into... Bruh. I didn't want to pull this up. I'm sorry. Although, I mean, it does show the same thing. 545 decape. Still not very high. Actually, this is a little higher shear relative helicity, but you can see this photograph is super tiny and super weak, and nobody wants a super tiny and weak photograph. You want a strong, a large photograph. Yeah. So, pretty dense storms over here. My concern is if they start to move to the west. That's my concern. Wait a minute. I'm sorry, I have a cold right now, and my brain is basically almost fully shut down, so... I highly apologize for my lack of intelligence right now, but what I meant to say was that the storms are going to the east, but my stupid head was like confusing the east and west because clearly we never soggy eat waffles here. Anyways, like I said earlier, storms tend to move off to the east. It just depends on how much energy is left. And that is something that will become clearer in the models as time goes on. Alright, looking at our next event. The next event odds actually have decreased over the last couple of days. Maybe it wasn't such a good idea to make that area of uncertainty, but oh well, it can't undo it now. It's like, it's not even the right plot. What am I thinking? So, back to this. This is what I was talking to earlier. So you see this Cape 500 joules per kilogram, PSFC 500 millibar, BS 40 knot, PV. What the heck does it all mean? Well, fear not, I will tell you. So Cape, we already know what that means. And what this is actually saying is that this is the probability that the Cape will exceed a certain value. Alright. So we know that. And then we multiply it by the probability of the surface to the 500 millibar height. And the 500 millibar height is just the point where the air pressure is 500 millibar. And what this BS stands for, it does not stand for Bull's knot, I promise you. It stands for bulk shear. And we are looking for bulk shear of over 40 knots because that supports storm organization. And that is crucial for severe weather. Now this parameter right here is just the chance that the precipitation from convection is over 0.05 inches. And what this is useful for is showing you where convection is happening. Because you can have the environment be perfectly primed for thunderstorms, but nothing happens if there isn't already a disturbance. You can see this pretty decent severe weather threat. But let's actually go on. So this could actually kind of tilt over a little bit, and it might actually affect parts of Georgia, as we saw in the NAM model. This boundary right here was a little more tilted over. So that's where the uncertainty lies. We don't exactly know where thunderstorms will set up on Saturday, but it is possible that they do set up over parts of Georgia and South Carolina, and that is something from like a tracking perspective. But let's go to a previous run because this run doesn't go out far enough. And let's actually go to next Thursday. So here we are on next Thursday. Now we have another severe weather threat to start tracking. And this one, once again, shows parts of Georgia, small part of South Carolina and North Carolina. Now I think that the reason why these percentages are so low is because we're quite a bit out. We are like 170, 180 hours out. And so naturally the probabilities aren't going to be this high. But I've seen these sort of systems in the past, and they do tend to produce at least low-end severe weather threats. And that's honestly what I'm expecting right here, is a low-end severe weather threat for parts of Georgia and South Carolina. I'm not expecting anything too crazy, but Mississippi, Alabama, Louisiana, they might get something, but here in Georgia and South Carolina and North Carolina, we're kind of like on the edge of the typical severe weather zone. So the pattern has to be unusually placed for severe weather to start to affect us. But so basically, here's what, if anything, what you should take away from this live stream. It's that severe weather is possible on Saturday today. What was that? Severe weather is possible on Saturday in parts of Georgia and maybe parts of South Carolina. We don't exactly know yet, but we will find out very soon. Probably tomorrow. Not just Saturday, also Sunday. Although Sunday will probably be a lot less intense than Saturday is. And then taking a look farther into the week, we can look at Thursday and Friday next week. Again, another potential severe weather threat. I'll have to monitor that closely because those kind of systems do sometimes produce severe weather in South Carolina, in Georgia, and North Carolina. So, I'll keep you guys posted on that. I'm going to end the live stream right now because I have other things to do. But if any of you guys have questions, just comment on my last video. I can't pull up the comments right now, so I'm sorry if people are commenting and I'm not answering them. Well, watch there be like 1,000 people watching my live stream right now, which there's definitely not, but oh well. It is my first live stream. What can you expect? Anyways, that's all I got for you guys. I will see you later. Let's just open the dashboard quick. Why am I still in? Okay. See you later.